Hello, welcome back to Cracking the Cryptic. I was going to be doing a gas video today, genuinely approachable Sudoku. I normally do 5 puzzles in a row, but I've postponed that till tomorrow so that we can do a puzzle for somebody's birthday today. Now, the brilliant thing is that Viking Prime, whose debut will be on the channel and whose birthday it is, happy birthday Viking Prime, has a real surname of Gas, G-A-S-S. Now, I don't normally reveal anything about constructors' real identities, but that is the case. So instead of doing gas puzzles, we're doing a puzzle by Mr. Gas. So I'm doing gas today, just not in the form that anyone expected. Now, I'm going to go through the rules. Then I will tell you a bit about what's going on the channel and the backstory of this puzzle. So normal Sudoku rules apply. 1 to 9 in every row, every column, and every 3x3 box. The normal stuff. Now, digits along an arrow sum up to the value in its circle. So those 3 add up to that one. However, there are 9 vampire cells contained within the grid, which are a set of the digits from 1 to 9. Each row, column and box contains exactly 1 vampire cell. So they might be disposed, I imagine, like this. That is 1 in each row, column and box. As long as they were a set of the digits 1 to 9, that would fulfill the requirements for the vampire cells. 9 prey cells in the grid follow the same rules as the vampire cells. And a cell may have only one of these roles. Now, what is it about these roles? For arrows and circles, prey cells contribute no value. Vampire cells contribute the sum of the digits in the vampire cell and the prey cell within the same box. Wow. Okay, so imagine that here we had a vampire cell there. We'll definitely make it red. And a prey cell there. And this might actually work, interestingly, because that prey cell would be contributing 0 to the value of this arrow, which would make it potentially right, I can see. This, the value this would be contributing to the circle in this case, would be the red cell plus the yellow cell in the box as well. So that would get it up to a number that could be fulfilled by an arrow. Now I've made 3 of the arrows blue so we can see which direction they're going in and make sure there's no conflicts. Like wanted to make sure it didn't look like an arrow going that way, I suppose. Oh no, it could have been an arrow going that way. Anyway, that's what I've done. So that's it. That's the whole rules. Now, what's going on the channel? Well, time is up on the Nightmare on Sudoku Street. Brilliant Sudoku pack by the Skunkworks Collective. They have done videos on how to solve them, and we'll be putting those up over the next few days on Patreon. So thank you very much to Skunkworks for that incredible pack and for the incredible videos as well. I've just realized, having read that rule set, I think this is going to be a long puzzle, a long solve. That's my guess. And I've got a drink over there, so I'm just going to get it. Sorry about that. My throat has not been at its best the last couple of days, so this may be necessary. Yes, thanks to Skunkworks. Also, thanks to Ashish Kumar for his wonderful puzzles that are used in the Super Mario Brothers hunt for kids. And we're getting a lot of adults who like that style of hunt that they can get through in a reasonable time, whereas the Skunkworks pack takes a lot longer. So do try the stuff on Patreon. There's also my crossword from a couple of days ago, the fiendishly hard, devious puzzle from the Times, and loads of other content always on Patreon. There's loads of other content on our apps, and in Sven's Sudoku Pad there's more, and just check it all out. There's the catalogue of all our videos and our merchandise. Some people still buy that. It's fantastic. We don't plug it much, and it gets very hard to update what shows on the channel's version of the web page, which is annoying. But if you go to the link under the video, there's a lot more stuff there. So that's all the stuff around the channel. Now let's go back to the backstory of this puzzle, where Viking Prime told us that a while back Simon solved a puzzle by Mad Tyus called Vampires. I remember it, by the way, which was the first puzzle I ever solved ahead of CTC and the most challenging I'd tackled up till then. Simon specifically made mention of a comment describing it as one user's most satisfying solve. That was me. And it was that combination of factors that got me setting in the first place. I was inspired. The first two puzzles I made were aggressively mediocre. That's very modest. The third, though, was a bit more challenging, better crafted, and something of which I'm still quite proud. I was very excited for that puzzle. However, not a single person solved it before it fell off the front page of Logic Masters Germany. I was crestfallen, just about ready to give up on the whole setting thing, but decided to post it up on Discord just in case. Mad Tyus saw the post, said they remembered my comment from their vampire puzzle, and so took the time to solve mine. They sent me a really touching message, giving me some encouragement and some advice on how to set and how to introduce new constraints. It meant a lot, I think more than they realise. Thus, I made the above-mentioned puzzle in tribute. It would mean a lot if you considered it for the channel. We have considered it for the channel, and I am going to try and solve it. So very well done. Well done, Mad Tyus. I'm not sure if you've had that encomium from Viking Prime before. Well done, Viking Prime, for getting this puzzle into this shape. Well done, me, for being prepared to tackle a vampires puzzle for the first time, which I'm looking forward to. And give it a go. Give it a go yourself on the link under the video. You may be able to judge from the video length how hard I will have found it, to use the future perfect, or that may reflect my own weaknesses. I may have become prey to the vampires in this puzzle. Anyway, let's give it a go. I'm going to restart my clock and say, let's get cracking now. My clock does restart, unlike Simon's. Well, there are clearly things going on with this arrow, which is too long. This arrow is too long. This arrow is too long. However, these can't both be vampire cells. This arrow is ridiculously long. And these arrows are too short. Too short, too short, too short, too short, too short. Oh my goodness. The trouble is, it's not just one cell in each box that we have to find, a vampire cell. We also have to find the prey cell. Right, where is it just de facto that we have to begin? I don't know, but this is quite powerful, surely. If we could put prey cells in 2 locations on this arrow. The trouble is, though, if you were to put a vampire cell in here, right? Okay. I think I've got something. So the total of this arrow adds up to a value here. Let's call it a value here. So whatever values we end up with on this arrow will add up to this value. And that will add along with these values to give that value. And even if you tried to minimize everything, you could have let's say a 2 and a 3 in those positions, and a prey cell contributing nothing. No, hang on. A 1 and a 2 in those positions. This would do it better. A prey cell contributing nothing. You could put a 3 here. Then you could have a 1 and 2 and a nothing here with another prey cell. And you would already be up to 9, and that's the minimum. This can't be a prey cell, or it would be the only one on the whole arrow, which would have to add up to a minimum of 12. So that is a value. And then we're only counting that once, whereas cells can duplicate in here, and 2 of them, and we'd have to count them twice. And I think 1, 2 there, 1, 2 there, and a 3 there gives us a 9 here. And I can see another reason why this is good. So 9 here, plus, well, again, one of these could be a prey cell. The others could be 1, 2, and 3 at their absolute minimum. And that's going to give us a value here of 15. And that's its absolute minimum, I reckon. So that is a definite vampire cell. Now that value could go up to 17 because that together with the prey cell in the same box could be a 9 and 8 together. So there are a couple of degrees of freedom around this. It's all on the Fistomephel ring as well, apart from that circle. I'm not sure I'm planning to use that technology in this solve. But that is a definite vampire. Now, I think we have to have a prey here, otherwise these would add up to 10. Basically, yes, you'd be adding at least 3 to my minima if you didn't have a prey cell, 1 in those cells, 1 there and 1 there. So there must be prey cells in those areas. I'm going to try and make prey yellow. That feels like the kind of most pale and ashen complexion someone could have when they get bitten by a vampire. Is it only lore in Buffy that if a vampire bites someone else, they make them a vampire? Or is that not? I don't know. Maybe I've entirely made that up. Anyway, that doesn't happen in this puzzle. Prey remains prey. Now, this cell sees vampire cells in all, prey cells in all direction, and that vampire cell. So that is non-vampire. Let's make it bright green for ordinary. I think that has to be a 9 because the minimum here, there was no other way to do this except a 1 and 2 there, a 1 and 2 there, and a 3 here. I'm even going to fill in a 3 there and a 9 there. The 3 is also, yeah, there's no point making it vampire because it can't get any bigger and it's clearly not prey. So I think we've got, I see, on this arrow, we get a 1, a 2, and a prey cell. Sounds like pray tell. Yeah, that must be right. This is a weird puzzle, isn't it? Now, this, it can't be a 9 itself. And we need a value of at least 15 from that and the prey cell in this box, which is not going to be there. Oh, it could be there, because it counts as nothing on the arrow. Could be there. And something significant for the circle. Oh, it's so strange, this. Right, 1 and 2 are also in these groups of cells, which actually on their own would have forced 1 and 2 to live in that 2 by 2 box. So putting them on the arrow doesn't actually achieve much. 1 and 2 are also... No, is it 1 and 2? And no, I said 1, 2, 3 are the minima here. But we now have 2 degrees of freedom. Does that allow it to be 1, 3, 4? Yes, it does. So 1 is definitely in these cells, a genuine 1, but I don't know about other digits. Now, once, I see this is going to get difficult. I want to have a colour that is non-possibly vampire, because I want to kind of find all the vampire cells. Maybe I'm doing better on the prey cells. Maybe I should look for those. See, okay, let's just do another thing. We've got a 4-cell arrow in this box coming to a circle in the same box. And that can't possibly work with natural digits. So that can't be a prey cell, because they'd all have to be natural digits. The vampire and prey would both have gone. So that is normal. These two are normal. That's normal. Maybe this will work with just one normal colour. And there is a prey cell somewhere on this arrow. Now, what about this arrow? There's no point putting a... Yeah. There's got to be a prey cell on this arrow. Because we have to reduce the maximum value of 1, 2, 3, 4 equals 10. We have to reduce it. The only way, if we added a vampire cell to this arrow, we could only increase it. We need to do something to reduce it. That takes a prey cell, which can't be here because that sees a prey cell in this row. So it must be in one of these places, and therefore there is not a prey cell in the rest of the column, and those can go green because they're in a box with a vampire cell. Now there's a prey cell here. These see a vampire and a prey cell. So does that. Now, what is this? This is a genuine number. And it's adding quite a lot of genuine numbers. It's adding at least 3 cells out of those 4. It's adding at least 3 cells out of those 4. Right, so it's 6, 7 or 8. Now I don't think it can be 6 or probably 7, because you'd have to count, if it was 6, you'd have to count 1, 2 and 3 as genuine numbers down here. Then these would be at least a 4 and a 5. And they're genuine. That would break the 6 total. I'm very worried the same's going to be true about 7 and 8, in which case I made a mistake. About 7, you'd put 1, 2 and 4 here. These would be at least 3, 5. That would break the 7 total. So I'm going to write in an 8 and see if it can work. Yes, it can. Yes, it can just. You can put 1, 2 and 5 there and a 3, 4 pair there, or 1, 3 and 4 there and a 2, 5 pair there. And it must work one of those way round. This pair adds up to 7 here. So here we've got a counting 1 and, well, I think it's going to be a 9, because this has now become not 8 since we placed an 8 in the box. But this has to be adding at least 1, 2, 3 and 9 equals 15. And that's made up of red and yellow in this box. So we have to get to 15 with this cell and whatever goes yellow up here. Well, it can't be 8, so it's got to be 9. But we actually don't know whether we're adding up to 15 or 16 yet. But 9 is the prey cell up here. 1 is the... Yes, 9 is the prey cell, 1 is the genuine. That adds up to 7. What's going on with this? Well, the remaining let's say that's a 2, 5 pair. The remaining numbers we would have are 3, 4, 6 and 7. That would have to be 3, 4 equals 7. And if this was a 3, 4 pair, 1, 9, 3, 4, 8, we've got 2, 5, 6, 7. So this always adds up to 7 as well. They're from 2, 3, 4, 5. This is a 7. And we've got a 6 in our first vampire cell. And therefore we're adding up to 15. So we are counting a 1, 2 and 3. Genuine 1, 2 and 3 along here. And a prey cell that could be, well, what could it be? It's some other number. It's not 9, 6, 8, or 1, 2, 3, which are all genuine there. So the prey cell is 4, 5, or 7. These are genuine digits, and they're from 4, 5, and 7. Well, they've got to be 4, 5, and this has to be a prey cell. Otherwise, this 9 arrow is nonsense. Wow. I love how this is flowing. It's not too hard. I mean, it felt like it was going to be absolutely insane. Now, this is not the vampire cell down here, because, sorry, the prey cell in box 7, because that is there. So this is a genuine cell that must be a 1 or a 2, because the counting ones on this arrow are 1 and 2. What is going on here? That's genuine. This has to be fake. It can't be a genuine 9. So that's a vampire cell. So these are green. These are green. I should maybe not be drinking lime juice. And we've got red there and yellow here, so these are green. Let's do a bit of colouring. I haven't got much red, but what this cell plus that equal 9. That's what the vampire thing means. Vampire plus prey here equal 9. So there can't be a 4-5 pair or a 7-2 pair in this row. Ooh, so they're either 3-6 or 1-8, and we have 1 and 3 looking up at this one. Oh, look, bing. No, I was going to say we've had a prey 1 up here, but we haven't. We've had a prey 9. I don't think we've had a prey 1 anywhere, so that doesn't resolve this as I thought it was about to. Now down here, right, column 9 is interesting. The genuine digits on this arrow are 1 and 2 numbers that add up to 7. The genuine digits up here are the other 2 numbers that add up to 7. So the genuine digits in these highlighted cells are 1, 2, 3, 4, and 5. So the prey digit that appears in these cells is not 1, 2, 3, 4, 5, or 8. It's 6, 7, or 9. And the vampire digit. Look, we've had a 6 in a vampire cell. This has to be an 8 because they're a set of 1 to 9. So that's a 1 to make this vampire cell contribute 9 to its little arrow. Now we've had a 1 in a prey cell. That's now a 2 in the corner. Now 1, 2, 3, 4, and 5 are the genuine cells here, and we've got 8 there. So these are selected from 6, 7, and 9. And what does that mean on this 2 set? What does this whole little conformation mean? I don't really understand it, because these 2, obviously this vertical arrow doesn't work, whatever these digits are. It's got to have a vampire cell within it, because it can't have a prey cell, because they've gone here. So this means that whichever one of these is the vampire cell is originally a lower digit than the other, and then somewhere in the box is a prey cell to make up the difference. I don't think I know which way round they go. I mean, they're just saying that's an equivalence. But now I'm trying to work out what's up with the blue arrow. Does that mean this is the prey cell, or does it mean it definitely isn't? I literally can't work that one out. I'm leaving it. I don't know what's going on there at all. 3, 1, and 2 can't be in this cell. Oh, but it could still be 4 or 5. In fact, it is a genuine cell, so it is 4 or 5. And 1 must be in that group of cells. Oh, I'm getting confused by everything now. These are all from 4. Oh, that is 6 or 7. Look, it sees 1 and 2 there somewhere. 3, 8, 9, and a 4, 5 pair. Now, these are from 4, 5, 6, 7. In fact, this arrow, which has no yellow prey cells on it, and also doesn't have a 1, 2, or 3 on it, it adds up to at least 15. This has to be a vampire cell. Yeah, it must be. Because that adds up to genuine values of at least 15. So this is another high vampire number. Right, we've got all 4 high vampire numbers. We've got a 6 there, an 8 there. Here, we're getting a vampire that's either a 7 or a 9. And here, we're getting another one that's either a 7 or a 9. Actually, here, weirdly, the vampire cell has to be lower than the other cell, because the vampire is going to make up its value by adding the prey cell. So the vampire cell here can't be the 9. The vampire here must be the 7. And it must be equivalent to the 9. And somewhere in this box is a yellow 2. I still don't understand what this blue arrow is doing. I will come back to that. But the red cell, the vampire cell, is a 7. So this vampire cell is a 9. And we've got all the 4 high vampire cells done. Now, 9 plus the yellow cell here is going to be the total of these genuine greens. Oh, and look, there's a parity thing going on now. Look, that... Yes, this is really weird. Remember that the yellow cell contributes to that circle total, but it is removed from this arrow total. So 3 plus the 1 and the 2, that's an even number, 6. 9 plus yellow equals the same as these 3 greens, and that must be an even number because you're adding 2x together, and 2x is always even. And that means this whole group of cells is even, but the total of the box is 45. Because a secret I sometimes share with my favourite people is that every row, column and box in a Sudoku must add up to 45 because it's the sum of 1 to 9. Anyway, if they all add up to an even number and the box adds up to an odd number, this one is odd. It is 5 or 7. And we can work out the total of this arrow. 45 minus 5 would be 40. 6 goes on the value of this arrow. That leaves 34. And then the value of these cells would be 17, which would be made up of 9 and 8 there and 7, 6, 4 here. That is entirely possible. If this was a 7, I wonder if this is going to be possible too. Then we're taking out 7 from 45 leaves 38. We're taking out the 6 that count there is 32. 16, oh, this doesn't work, definitely. 16 is not possible, not only because that would be 4, 5, 7 and reuse the 7, but the 9 and 7 to make 16 would also reuse the 7. Right, that's a 5. That was worth doing. Now, what was the maths? 40... minus 6, 34, 9 and 8. This is now a 1-8 pair, and the 8 is the prey cell. And this is a 4, 6, 7 triple in the green, which does add up to the 17. Okay. Oh, been through the ringer in my mind there. Now, what about these prey cells? We're having a 9 here. We're having an 8 here. We're having a 1 here. Oh, we must know what we're having here. It must be 7 that is the prey here. It must be. There is a 7 in those cells. So we've had 9, 8 and 7. Do we know what the prey here is? It is either 6 or 4. If it's not 9, 8 or 7, it can't be 1 or 2. 3 and 5 are gone in the column. It's either 6 or 4. And here I don't know. Now, was there a lesson from this 2-cell arrow? Because I've got loads more of them going on. I thought there was a 5th one somewhere as well. Maybe there were only 4, or maybe I'm just being blind. I mean, that one we've done. Weren't there 5? I thought there were 5. Maybe there's only 4. Anyway. Well, yes, there must be a funky cell going on here, and it can't be yellow because that's over here in the box. Same is true here. There must be a funky cell there. It must be red, All of these in the boxes, apart from those, are green. This pair needs a funky cell as well. And again, it must be red because yellow can't be there in the box. So we are getting on famously at isolating red cells now. That's gone green. It sees both red and yellow. Getting nothing done in the central box. But red is going to have to be either there or there. And either there or there. It's a last little X-wing of red cells. Yellow, don't know, because we know so little about where yellow goes in these boxes. And I do think that, as we learnt here, 7 and 9 taught us that all we know is that red is the lower cell, but we don't know which one of these, whether it goes in the circle or the arrow. It doesn't really make a difference. And we've had, what have we had in red? We've had 9, 8, 7 and 6. Now, here it's not going to be 2 or 1 because they're in different positions in the box, and here, and here. So here the red cell is going to be a 2, and here it's going to be a 1. Wow, that's weird. So those aren't 1s. I'm not sure how we can use that to solve anything, if at all, yet. What about yellow numbers? We've had 9, 8, 1, and precious few other indications of definite. Oh well, 7 here, 6 or 4 here. Here it can't be 1, 2, 3 or 9, so it could be 4, 5 or 6. Here it's got to be 6 actually, because the counting digits will be from 1, 2, 3, 4, 5. Right, okay, I need to think about the prey numbers. So we've had 9, 8, 7, 6. This time it must be 4 and that one must be 5. Yep, that's got to be right. So there's a prey 4 there and a prey 5 here. That's going to get me something done here. That makes this a 4. Now this isn't a 4-3 pair, it's a 2-5 pair adding up to 7. That's a 4-3 pair. It's not a 4 because that's a 4-5 looking at it. So that's a 3, that's 4. This is now a 1-2-7 triple, with 7 being the prey. This is a 1-2-4 triple, with 4 being the prey. This is not a 4. Oh, that's not a 4 either, so we've placed 4 in box 7. This is a 1-2-5 triple with 5 being the prey, and that is a naked 8 because it sees 6 and 7 in the column. That is going to be, oh, this is 6 or 7, but that sees a 7-9 pair. So all resolved. Now I've got to figure out this arrow. This has probably been available forever. I kind of think this has to be a 2. I think this is the prey 2, isn't it? Because how can this arrow work? We're just as in this arrow, we're looking at a vampire 7 that adds on to its prey 2 to make an ordinary 9. Well, that must be what's going on here. So the prey is just ending up on the arrow. So this has probably been available from, well, the conclusion that this is a yellow cell has, I think, been available from the absolute start. And if you started with that when you solved this puzzle, take a gold star for understanding how it works, because I didn't. I think that actually, in this case, that does tell us which way round it goes. Does it? If that was the ordinary 9, no, it doesn't. It still doesn't. Okay, I really don't understand this concept, do I? So we get a 3 there, a 1-5 pair here. They're all resolved. They're also all green. 1 and 8 are now placed here, and I can therefore, oh well, I could have coloured that since I got the 2. That's green, that's yellow. Now if I could just unwind some of these cells, oops, that's wrong, here's another one. We're identifying where the actual yellow cells go, and that might make it a little easier to understand which ones we've used up. We've used up 9, 8, 7, 6, 5, 4, 2 and 1. In this box we've got a yellow 3 to come. That's green. Where does the yellow 3 come? I haven't got a clue yet. We've got a yellow 3 and a red 1 in this box. Oh, do we know what the digit up here is? What have we done in red? 9, 8. Have to check again. 7, 6, 2, 1. Ah, this one can't be a 5 here. So it's 3 or 4. This one, oh no, that's the 2. What about this? No, I don't know. Okay, well, I just have to work on it. This is now a group of 1, 3, 6. Oops, with 6 being the, I want to say liar, but I just mean prey, the hapless victim. Oh, and I hadn't really understood this, had I? 2, 7, 8. Well, this is a useful group because 2 is in this group. So the difference between vampire and real, which equals prey, is either 5 or 6. Well, it must be 6. So this is a 2, 8 pair. The vampire is a 2. The genuine cell is an 8. This, my friend, is a 7. Now, what about over here? We're going to be using a vampire of either 4, 5 or 6. And a difference of either 1, 2 or 4. No, the difference is definitely 4. I don't know. I'd rather do Sudoku than work that one out. I'm sure there is plenty to do at the moment. These are from, oh well, 3, 7, 8, 9. Now we know what digit was going to be. Did we know? No, maybe we didn't. It's going to be a middly digit, I think. So the digits that we have left for vampire cells are not 9, 8, 7, 6 or 2. They are 1 there and then 3, 4 or 5. But we're looking at a 5 difference between the vampire and the ordinary here, because that's the value of the prey. So this is either 3, 8 or 4, 9 here, isn't it? Yeah, it is. Do I know which? I don't see how I know which. Oh, what about up here? I don't know. I don't even want to think about that. 4 and 8 are up there somewhere. 7 is in one of those. Oh, I've got a 4 that's doing some Sudoku, right. 5 and 9 are in these cells. Now, what's on this? I still can't remember. We've got, is it 3, 4 and 5 to use as vampire numbers? It is. This is 3 or 5 as the vampire number here. And then the difference, the prey is 1, 2 or 4. No, it's not. The prey is 4 in this box. So the vampire number is 3 or 5. And the genuine number, therefore, is 7, which it can't be, 1, which it can't be, or 9, which it can be. That is a 5-9 pair. We're using the vampire 5 there. So here we're using 3 or 4, and here we're using 3 or 4. Oh, it's so hard. I don't think I've been very rigorous with the pencil marking, probably. 5, 9, 1, 2, 4. We've got, these are all from 3, 6, 7, and 8. Now, I haven't thought about this arrow at all, or actually this one. I haven't really wanted to think about these arrows because they seem to have so many possibilities. I suppose there is every chance that the 2 remaining vampires are in circles. don't know. We've got, okay, let's think about this box. We've got a prey 3. But you could also have a prey cell here. Oh no, you couldn't have a prey cell there. Yeah, you could, because the I don't know, the difference between those two would then be 3. One of them is a vampire. Wow, I don't know what to do. How do we sort this out? I've got so little going on in columns 4, 5, 6, and so much done elsewhere. The low digit here is the vampire cell. Oh, this can't be a 3-8. That can't be 3 or 8. It's not a 3-8 vampire. It's a 4-9 vampire. And this one can't be the 4. So that's the 9. That's the 4. Right. 7 and 9 there. Now, the low ones are the actual vampires. These ones are genuine digits, both 9s. 8, 4, so we're reduced to pairs in the rows. Now, what's going on this arrow? 4 plus 5, which is the vampire digit, is 9. They have to add up to a genuine 9. 3 and 6 there. Now, is this going to look up the grid at all and help? Really barely at all. What about 9? 9 now can't be in any of those cells. Okay, so it's in a genuine non-arrow cell up here. Now here, oh, we've got a 7 prey number. So that is going to add to the vampire number in one of these cells. Well, that can't be the vampire, because that would be at least a 2. It can't be a 1. Plus the 7 there, plus something here is going to burst a genuine cell here. So this is the vampire. The vampires are in the circles. These are not vampires. They're genuine cells. Don't know about this, actually. It could still be the yellow 3, now I think about it. Just the fact that it's not red doesn't mean it can't be yellow. So, what is this? It's not. Oh, well, it's a vampire cell. What ones have we got to place? 5 there, 4, 7, 9, 8, 6. There'll be a 2 here. So we've got 1 and 3. That one must be the 3. That is the 1. I think maybe I knew that before and I'd forgotten it. I certainly knew that was a, well, whichever one of these was a vampire 1 was a 1. So these two cells are adding, oh, they're adding 1 and a prey of 3. They're making 4. And, oh, hang on though. I was going to say there must be a pair of 2s. But that could be another prey cell, and that could be a 4. Since it can't be, this can't be a 1 or a 3, and it's adding to a value of 4. Oh, but this could be a prey cell. No, it can't, because that can't have a value of 4. So this has to have a value. It's either a 4 with a prey cell there, or it's a 2 with a genuine 2 there. Now I've got a 2-4 pair in the row. It's so complicated. I thought it was going to get easier once we got all the prey cells, all the vampire cells identified. That's not a 1. Oh, that's not a 1 now. Now, this is adding 3 and a 7, 10. These two add up to 10. This one can't be 1, 8, 4, 7, 9, or 3. 2, 5, or 6, but it can't be 5 because it would need another 5 here. This is now 4 or 8 to make up that sum, and I don't know which. This can't be a 2 because that's a 1, 2, 7 triple. I do know which. 6 and 4. That's not a 6 now. 4, 3, 6, 1, 2, 7, 8 in the box is there. This is a 5, 9 pair. I'm a poet and I think I know it. That's become a 2. That's a 5. That's a 3. This is a 2, 6, 7 triple, isn't it? In fact, that must be where 2 is then. Yeah. 2, 3, 4. That's become a 6. That's not a 6, and therefore is not the prey cell, because the prey cell is a 6 there. That is not a prey cell because it's not a 3 now. In fact, these aren't 3s either because they're in a column with a 3. So that is a genuine digit, adding 4 as the value for this, 1 plus the 3 of prey, plus that. What can this be? 1, 2, 3, 5, or 7. But if it was the 3, it would be prey. Does that mean it can't be there? No, it can't be 1. 1, 2, 3, 5, or 7. So 4 plus, well, if it's 7, it's not prey, and then it's not genuine because it would add to 11. So it's either 4 plus 2 is 6. 4 plus nothing, if that's a 3, is 4, or 4 plus 5. So this is 4, 6, or 9. Oh, it's such a strange puzzle. Oh, that 6 has sorted out the pair at the top. No 3 in the corner in this puzzle. Another way it's strange. This is 2, 3, or 5, just by elimination of other things it sees. But there's a 2, 4 pair in the row, so it's 3 or 5. I still need to sort out some of these prey cells. Well, and these last 2 vampire-y ones, I suppose. Wow, I'm just getting more and more confused. There's an 8 in one of those 2 cells by Sudoku. That doesn't seem powerful. What about this column? 3, 8, 7. 1, 2, 5, 4, 6, 9. That is not a prey cell. Oh, that's useful. Because it's 1 or 2 and they're genuine on this arrow, the only place left for a prey cell in this column is here. So that is prey. They're not. The prey one is the 5 in this box. Now, that 5 looks up here, gets a 9. Now this is a 9, 8 pair. In fact, this column is all unwinding apart from that 9, 8 pair. The 7 is the prey cell in this row. This is a 9, 8 pair. They're genuine. Now, one of these is the prey 3. Oh, that can't be a 9 anymore. So this can't be a 5. Oh, there's a 2 here. We've done it. We've done it. 2, 3 in the middle. That is the prey in the middle. That's 3 in the spotlight, losing its religion there. And this is a 4 to make the sum work. Wow. Yes, this now works with 1 plus 3 equals 2 plus 2. One of the harder math sums I've done lately. That is not prey for many reasons. This is a 4, and that is the prey, and these aren't. And I've still got 2 vampire cells to unwind. The last 2 vampires to clear out of Sunnydale. But let's do the Sudoku first, which is probably what I would do in the event of a real vampire attack. 1, 2, so that 2, right, that sorts out 8, 2 there, 8, 9, 5. And before I put in the 9, the 5 and the 2 are the vampires. The 8 and the 9 are genuine digits. And this is the solution to Blood-Cursed Arrows by Viking Prime. Happy birthday, Viking Prime. There we go. Oh, what a brilliant puzzle. 42 minutes. I'm quite pleased with that. It looked terrifying, like a vampire. It was just about manageable to get going with, but then it got really sticky as the vampire struck. There we go. That is Blood-Cursed Arrows. Thank you very much. We'll be back for a more normal gas video tomorrow. But thank you for watching. Hope to see you again soon, and bye for now.